Hi, Professor. I hope you and your folks are doing good and staying safe out there. So this session is about the project presentation. And as per the guidelines, I have recorded this video using Zoom app, and I'm uploading it on YouTube and sharing the link. Well, this project is about building a gun detection model using deep learning. Well, this is the agenda for this session. We're starting with problem statement and then introduction. We speak about the small arm survey and then few more topics as listed there. And finally concluding with the conclusion, future scope and references. Talking about the problem statement, we know that mass shootings and homicides are not new to us, and it is a big problem here in the United States. For that reason, all over the world. Uh, and the recent shooting last year in Sagas High School in Santa Clarita, I think during last semester end, when I approached you with this project proposal, we did speak about this incident and which was new at that time. So this particular incident actually motivated me in order to take up this project, and hence we discussed about it. And I'm glad that you accepted this project proposal. Well, well, to be speaking in particular, the ease of obtaining these handheld guns by general public here is a big reason to worry. Well, introduced after every mass shooting reported in the media and after every minute of silence, the question of gun control is always in the highlighted thing. And this paper, especially my project, doesn't diverge into discussion regarding the gun control laws or anything, but in actual focuses on the machine learning and artificial intelligence, particularly the deep learning techniques which we could implement in order to detect the handheld guns and other images, so that we could alert the respective parties. Like I said, prevention in this regard is always a good thing. Well, in last year, I think in 46 weeks, there was like more than 44 cases just shootings that happened in the school, and it was reported in CNN. And the one which recently happened was at the Sagas High School in Santa Clarita, where at least 2 children were killed and several others were injured. Well, to speak in general, there has been at least 21 deadly shootings in US in 2019, and we could see the map here where the most affected places here. Well, speaking about the Small Arms Survey, it's an independent research project located in Geneva, Switzerland, and they have come up with uh, several findings. And as per them, the handgun detection is not yet perfected as an object detection project. And there's a lot of benefits if this particular technology is improved. And by end of 2017, there were approximately 1,013 million firearms in 230 countries, which we think is a big reason to worry, and of which estimated 84.6% were held by civilians, 13.1% by the military professionals, I mean military state military officials, and 2.2% by law enforcement agencies. Well, this particular chart show an estimated total civilian held legal and illicit firearms in 25 top-ranked countries, and United States stood in the first place, followed by India and many other countries. Here, another one which shows estimated rate of civilian firearms holding in top 25 countries, and United States stood again in the first place. Well, another graph which shows the annual acquisition of new firearms in United States, and the acquisition actually raised a lot during the year 2012 and 2013, and it continued at the same rate, and I'm damn sure it wouldn't have reduced by end of 2020. Still, it would be the same. Well, uh, the research related to the hand held gun and other object detection things is not new, and a research paper by Almost Tabik and Herrera, which I have used in my project to take a few little ideas from his paper. He says that psychological studies demonstrate that the simple fact of having access to gun increases drastically the probability of committing violent behavior. which actually we think is true. And in most cases, like I said, early prevention and detection of firearms, particularly handheld guns, are key to preventing such behaviors. And for most part, past studies have focused mostly on using X-rays combined with some traditional machine learning methods, which I think were not that effective. However, the recent research, which incorporated the deep learning and other AI-related aspects into this, which ultimately have performed better than traditional machine learning tools. Well, the resources and the environment which I used for developing this project included the hardware resources, and that's my system, the laptop which I used. We had 6th generation processor, if I 6th generation processor, 12 GB RAM, and I had a graphic card too. And the second group would be the concerns about having the software and development tools that I used, Anaconda environment, and I used TensorFlow with several Python packages, ports like NumPy, Anaconda, Protobuf, LXML, Python, DB, and many more. Third group is for the documentation purpose, where I use MS Office. Talking about the project methodology, well, possibly the most challenging task for me was sourcing the data set. And I sourced them from several online open source platforms. In addition to collection of these ones, I installed TensorFlow on my system, and then I used Anaconda environment through which I worked on this project. I imported default Python packages like NumPy, and then Google Protobuf, LXML, Python, OpenCV, and a few more. And after that, I downloaded the TensorFlow models and object detection softwares. I downloaded it from the TensorFlow application Zoo through the Google's repository, a holding repository for all existing object detection and image classification projects. There are many models out there. In my case, I used 2 models. One was SSD Inception V2 Coco for testing purpose. I just used this project for testing purpose. I run around 3,000 steps. I mean, I trained the model for 3,000 steps and I stopped it. That is because it was just for the testing purpose. But my project as a whole to run, I used faster RCNN Inception V2 Coco model, which I thought was better than the SSD Inception. So after that, I installed the label IMG, using which I annotated the images, dataset images, the test and the train images. I used totally 6 classes, of which 1 class was the main one, which was handheld guns, and the rest 5 I used for training were person, hand, car, binoculars, and knife. Well, the training set comprised around the training set comprised around 800 pictures, which 10% I used it for testing, and I annotated the images using the label IMG, and then from which I got the .xml files, and then I used scripts, Python scripts, in order to convert the .xml files to CSV files, and then later I used a few more scripts to convert .csv files to the TensorFlow records. And the last step was configuring the training pipeline to detect the objects. Well, the faster RCNN model, I trained it for about 20,000 steps, and then I exported the trained inference graph, using which we could test the random handgun images downloaded from the Google for detecting the handheld guns. Well, I have recorded the video for SSD model, both the training and the demo, and I have uploaded in the project files, which you can find it in the link. And I'm just having the SSD model results here. So from that results, the trained model, I could detect the handgun, and it detected 97%. And the person was detected 59. This is because I used very less pictures for training and testing the person. So in general, my main intention was detecting the handgun. So let's go with it. So here it's 97%, and here I guess it's 99%, which is a good number of for me to consider the accuracy of this model. However, I still consider using my faster RCNN model. Well, the faster RCNN model training video here, I just made a small video using the same Zoom app. Um, I was training the model. Actually, this video is like 5 minutes long, so I'll just skip a little front so that we don't take a lot of time, and we can use the time in actually showing the actual video demo project. So I'm just going into the Anaconda prompt, going into the TensorFlow directory, and I'm running the model. So it started the summary. The last summary was at step 20,000, and after that it started with the new one. I made sure that the loss was less than 1. Ideally, that is the best suitable thing in order to look forward. So the beauty of TensorFlow is that we have something called as TensorBoard. So during the training of a model, we could actually check the logs of these using TensorBoard. So we can check through the port number, and we could go and put the port number in the browser in order to check the graphs and the loss. I mean, the graphs about the loss and everything. I'm just doing that here. I'm just running this syntax. So this is the port which I meant. And if we fix that, the browser. So these are the loss graphs. I have uploaded this video to, I have included this video to in my project files. So for your reference, maybe you can go ahead and check the video. Just to save time, I'm just pushing forward as of now, so that we could get into the demo, actual demo. Well, to go ahead with the project demo. So I have my project files and everything set up here. User. So here, these are the files, the project files. Here I have the label img, which I have installed, using which I did the annotation of the images of the test and train data. And then the models, which I said that I downloaded from the Google's repository. These are the files that from there. And then the scripts, which consists of 2 scripts, which is one which I said the annotated images, which I converted from .xml to CSV, and then from CSV to TensorFlow records. And this is the video of the SSD training and demo. Then coming into the workspace training demo. I have annotations here. This is the label map. It's a pptxt file which has all the classes that I have annotated. First one is the handgun, and then person, car, hand, binoculars, and knife. Then these test and train are the 2 files which I converted from XML to .csv format. And then this to test.record and train.record are the files which I converted from CSV to TensorFlow records. images I have to train, where I have all the train images that I use to train my model. Test images are the images that I use for testing while training my model. So ideally, I have kept 90% and 10% here. So pre-trained model, or these are the files related to the RCNN, faster RCNN, and then uh, training folder, which consists of my configuration file, that is faster RCNN inception v2 Coco config file, and then I have these model CKPT files, checkpoint files. So that is 20,000, using which I imported the train inference graph, and this is that particular file. Then finally, I have export inference graph, the script which I used in order to export the train inference graph, and then train script which is used for running my model. Quickly getting into activating my TensorFlow environment. So I launched the Jupyter notebook. We go check out the output, go to the research, and then there you go. So these are the test images that I have used, which I downloaded randomly from Google, so that I can have this as input for my model and check. These are the pictures, the test images. Let's this code in order to run my model for the picture that I have downloaded from Google. So let me repeat it again, that the model which I'm using here is faster RCNN. Um, there is a lot of difference between the previous model which I used, the SSD, and the faster RCNN here. So using when I train my model using this, I did a lot of steps that I followed, because of which I'm able to detect the hand tool here, which you can see in the image. So the handgun detection detected 95% in this picture, and hand 64%, because I used very few pictures in order to train the hand. This was one tested image. here it is. The picture here, the handgun was 96% and hand 59%. Your hand was 52, and then handgun I think 80 something. The other one. So here it was 95%. And here 91%. This picture. And then here hand was 59 and handgun was 95%. So this was the demo. Well, in order to conclude this, like I said, this paper doesn't divulge into the discussion regarding the stricter gun control laws or limiting this ammunition by general public, but instead focuses on use of machine learning and artificial intelligence in order to identify the firearms. Well, I did check with other input images too. Well, according to that, when I checked, the model predicted the labels with accuracy as high as 97% when the image was in a good contrast with background. However, when the background was not that great, the accuracy that I saw was 64%. So in terms of speed of detection, it took a few extra seconds like we saw to identify the object, well, which creates a lot of room for us for improvements for real-time object detections further. About the future scope, I want to integrate this model into the live video surveillance and high-end CCTV cameras so that we can use this model for detecting the guns in public places and public gatherings.